This is a fun related rates problem. So we have this light that is 10 feet away from a wall. So that right there is a perpendicular measurement to the light. So here's my light shining. The light is also spinning, and it's spinning at a rate of 1 rotation every 2 seconds. We want to find the rate at which the light projected on the wall, so here's where the light is projected on the wall there. When the light's angle is 15 degrees, so let's call that theta right there, 15 degrees from the perpendicular. So the light is moving, so the movement of the light would be, it's going in this direction at this instant if I'm rotating counterclockwise, and the rotation doesn't matter too much. So let's call that x there, that distance. So we have two things changing. We have the light rotating, so the angle is changing, and then we have the distance to the perpendicular here is changing. And that's kind of cool because as you know, the rotation goes this way, this is heading out toward infinity, but this is a finite, right? This rotation is just kind of like a finite thing. So that gets weird out on the edge. So we're not going to go there today, I don't think. All right, I think we're ready to go. So what is the relationship between the angle and x? Sometimes it helps to redraw this. So I've got this right triangle here. Where this is x, this is theta, and this is 10. And since we're involving theta, we don't want to use the Pythagorean theorem. We want to use a trig function to engage the angle there. So opposite over adjacent, tangent. Tangent theta is equal to x over 10. Cool. We want to find here dx dt. Right, we want to find the rate at which the projection of the light is moving along the wall. So that's what I was calling x, the movement along the wall, the distance from the perpendicular with respect to time. Now the rotation every 2 seconds, this is important in calculus. Angles need to be, especially with trig functions, need to be in radians. So I need to think about this rotation in terms of radians, and so the important thing there is that one rotation, one trip around, is 2 pi radians. So then d theta dt, theta has to be in radians in order to take the derivative of tangent, call it secant squared, has to be in radians. So we have one rotation, or 2 pi radians, every 2 seconds. And that cleans up just a little bit. 2 divided by 2 is 1. 1 times pi is pi, so we get pi radians per second. And then other problem is we're given at that instance theta is equal to 15 degrees. Degrees is a problem, so we're going to have to convert that. So to convert, we multiply by pi radians is the same as 180 degrees. To get rid of degrees, 15 goes into 180, I believe, 12 times. So this would be pi over 12 radians when we need it. Okay, I think we got everything we need. So up here, we need to differentiate. So we want to find the derivative with respect to t of tangent. And that's going to be equal to the derivative with respect to time of x over 10. Derivative of tangent is secant squared. And then we have to multiply by the derivative of theta, which is d theta dt. Because theta is changing over time. And this theta is not a t. Chain rule says. 1/10 is a multiple, so that just gets carried along, and the derivative of x with respect to time is just dx dt. So then we just get to multiply the 10 to the other side. So dx dt is equal to 10 times the secant squared of theta times d theta dt. We have all of those. So we can then, oops, that doesn't look like t down there, it looks like an x. So I think we're ready to plug in. We've got the 10 and times secant squared of pi over 12 times d theta dt, which is just pi. If we want an exact answer here, we'd have to evaluate the secant squared of pi over 12. So I would do secant is 1 over cosine. So this would be 10 pi over the cosine squared of pi over 12. And then we could use the half angle formula on that, because this can be written as cosine squared of 1/2 of pi over 6. So let's look up the half angle formula and get an exact answer on this, and then get an approximation. So trig formulas, identities, can't spell, go, purple math, trig cheat sheet. Let's try the trig cheat sheet today. All right, and we are looking for the half angle, here we go. So it would be plus or minus depending on where the angle is. And so we're gonna have the plus, so the square root, and we're squaring it, which is nice. So 1 plus cosine of the angle over 2, okay? Let's see, where are we? So the cosine squared of that is gonna put in the bottom, switch to, I'm already in green, so I've got my 10 pi divided by 1 plus the cosine of pi over 6. And all of that is over 2, so I can put that 2 up top, multiply by the reciprocal. Cosine of pi over 6, so thinking about the unit circle, pi over 6 is this lower angle there. Cosine down there is square root of 3 over 2. So the exact answer would be 20 pi over 1 plus the square root of 3 over 2, which could be cleaned up a little bit, but not too much. Multiply top and bottom by 2. I really don't want to rationalize the denominator there, so I could say it's 40 pi over 2 plus the square root of 3. So let's test to see if I did that right by plugging this into the calculator. The unsimplified version with the mostly simplified version right there. So my first draft of the answer had 10 pi divided by the cosine squared, or we could have gone with the secant, oops, pi over 12. Let's see, make sure we type it right. 10 pi over cosine squared, or 10 pi times secant squared. Check that one too. Should be a master of your calculator, just for fun. 10 pi times secant squared, pi over 12. And it doesn't like, probably the secant squared. Oh, doesn't it like? Doesn't like something I typed. I didn't freak out. And pi's okay. Secant? Doesn't recognize secant? What? That's weird. Oh, they don't have secant in here. I swear they had secant. Interesting. All right, so we have to use the cosine there. The other version I ended up with was, what was that, 40 pi divided by 2 plus the square root of 3. Ooh, I got an error somewhere. There's no match. Okay, it's back. Where'd my notes go? There we go. Okay. So cosine theta over 2 is equal to the square root of 1 plus the cosine of theta over 2, right? Right here. And then I'm squaring that. So cosine squared of theta over 2 is just 1 plus the cosine of theta over 2. So here's my cosine squared of pi over 12. Pi over 12 is really pi over 6 over 2. So there's my 1 plus cosine of pi over 6. And then divide by 2, I multiply it into the numerator. Am I right about this? Cosine of pi over 6. Pi over 6 is down here below pi over 2. Cosine is pi over 6 is square root of 3 over 2. Sine is 1/2. That looks right. Multiply top and bottom by 2. 2 plus square root of 3. Interesting. I don't see the error. I do have an error. Fascinating. Let's see. Correct answer 33.7. That's the second one. So I have an error. I mistyped something here. Okay. Secant squared of pi over 12. That looks right. How did I mess that up? 10 pi over the cosine squared. 10 pi over the cosine squared of pi over 12. Why would these two be different? Oh, interesting. Maybe I need to square the whole denominator. That correctly? No, it still gives the same answer. I don't see the error. Fascinating. You see it. Write to me. Let me know. One more look, and then I give up. Start over. And pi. Secant is 1 over cosine. Pi over 12. How can this be right and that not? Weird. It's a mystery.